section 7.6, I put a copy of original problems and key on Canvas. So I think it's a good idea for you to print that, and while you're watching this video, you have a copy of the key and original with you. Here we are talking about how to solve a radical equations. Now, if you have radical x is equal to 3, the question is square root of which number is 3? Obviously that number would be 9. If I use my calculator and take square root of x, square root of 9, calculator would give me 3. Or you understand 9 is 3 to the power of 2. The root is 2, so 3 is released from the radical. The other way to do this is if you square both sides, radical x to the power of 2 is x, and then you have 9. That's how to find without guessing a number. When you take a radical and raise it to the power of 2, basically what you do is you take a radical and multiply by itself, right? When you take a radical and multiply by itself, then you combine this into one radical under the radical, you multiply these two, which is x to the power of 2, and that would release the x. Like if you have radical 5 times radical 5, that is radical 5 times 5 was 25, which is 5. So in that case, anytime you have any number under the radical, let's say you have something like this, 3x plus 1, right? If I take this and raise it to the power of 2, then again we have, that means you take 2 radical and multiply, which is that, and 3x. So it doesn't matter what you have under the radical. When you raise it to power of 2, radical is removed. What if you have a number next to the radical like this? When you raise it to power of 2, again it would be 2 radical x plus 1 times 2 radical x plus 1. These two numbers, when you multiply, is 4. And when you multiply these two, you just have x plus 1, right? Or if you have negative 3 radical x to power of 2, again it would be minus 3 radical x times minus 3 radical x, which is 9x. So we use this property here for these problems. I have radical 5x equal to 10. So I raise both sides to power of 2. Radical is removed. So all you have is just 5x equal to 100. 5x equal to 100, divide both sides by 5, so x is 20. One thing about the radical equations, make sure you always check your answers, because there are some equations that they are undefined, but when you solve it, you may not notice that, and you come up with the answer, and you think the answer is correct, however, is not. Is like this one. I'll show you how to do it if you don't understand that this problem is there is no solution. So I'll take both sides to power of 2. Again, by raising radical 2x, radical is removed, so all you have is just 2x equals 36. X is 18, right? But now I want to check, because my solution is correct. But when I put 18 here, 2 times 18 is 30. Is radical 36 negative 6? No, it's 6. So this is undefined. The reason is this. Radical, when you have a radical and the power is 2, number under the radical regardless what it is, 9, 10, 16, the outcome always has to be positive. It cannot be negative. So anytime, that's not correct for odd numbers. Let's say I have minus 27. What is that one? If I use my calculator, cubic root of minus 27, the calculator give me minus 3. But if I use like 4th root of minus 16, calculator doesn't give me 2. Is undefined, because you cannot have the negative number when the root is even. And you could always use your calculator would tell you. So for that reason here, if you have a radical which root is 2 or 4 or 6 is an even number, on the right you cannot have the negative number. Again, if you don't notice that, you could solve the problems, and then while you're checking your answer, you find out. Here, anytime you want to raise the radical to power of 2, you want to make sure radical is sitting by itself on one side. Okay? So here, first I have to move negative 2 to the other sides by adding positive 2. See? So you write it like this first. Radical isolate on one side by itself equal to 7. So when you raise both sides, radical is removed and you have 49 and x is 7. Here, radical has to be by itself. So you move 2 to the other side. Now, because the root is 3, we don't raise it to the second power anymore. We raise it to the third power. So radical is removed. So if you have here radical x, when you have a cubic root of x, when you have cubic root of x, if you raise this to power of 2, what happened? It happened radical x, cubic root of x times cubic root of x, which is cubic root of x to power of 2. Can you release x? No, because this power should be the same. So if you have a cubic root of x and raise that to power of 3, then you have 3 of them. In that case, you have cubic root of x3, 3 and 3 cancel, so it's x. Okay, so it depends what the root is. Like if I have 4th root of, let's say, x minus 1, raise it to power of 4. So in that case, you have 4 of this. Then you have x minus 1 to power of 4 and 4, you see? 4 and 4 cancel, so x minus 1 is released. So whatever the root is, you need to raise both sides to that power, the power of these numbers. That's why here we raise it to power of 3. Number 5. I have the solution for you for number 5 and number 6. See? This is for number 5. I want to keep radical by itself. So I move radical to this side, this minus become positive. I move negative x to the left, which is positive. So now radical is by itself. When I raise it to power of 2, 4 minus 3x is released from the radical. On this side, you have x plus 8 to power of 2. X plus 8 to power of 2 is what? Is x plus 8 times x plus 8. And when you multiply or when you distribute x, then you have x2 plus 8x plus 8x plus 64. which is x2 plus 16x plus 64. That's where we got this from. And then we want to have everything on one side. That's where you get it. And then you use the factoring. And these are the answers. Now, when I find the answers, remember I said with the radical, although your solution is correct, maybe one or two of the answer does not work. Like I check here. When I check by taking the number back into the equations, when I put negative 15, when I put the negative 15 here for the x to see if the right side is negative 8 or not, it's not negative 8. I turn out to be minus 23. So x because of negative 15 is not the answer. But negative 4 is okay, because when I put the negative 4, then both sides are negative 8. So it's important for you to check your answers. And this is number 6. It's a very long solution. These are the problems that you probably have one or two in the homework, but you won't see that on the test because it has long solutions. All right, so I raise both sides to power of 2, and then you have this, means you have to take 2 of these. See here? This one means take radical x minus 38 plus radical x plus 7 and multiply by itself. Is you repeat that, right? So when you do this, look, when you multiply a radical by itself, that gives you x minus 38. Or when you take radical x plus 7 times radical x plus 7, when you take a radical and multiply by itself, it gives you x plus 7. And then when you multiply by this, you have another x plus 7 times x minus 38 and another x plus 7 times x minus 38. That gives you 2 of them. So you take these 2 to the other side. Now here, I see all the numbers and the term, they all have, they're divisible by 2. So I just divide everything by 2. So see, radical is by itself on one side. Raise it to power of 2. Again, remember, 56 minus x means 56 minus x times 56 minus x. When you multiply that and simplify, that's what you get. So these are other long problems. First, you need to isolate radical by itself. Radical has to be on one side by itself. So I move negative 3 to the other side. Raise both sides to power of. When I raise to power of 3, 8x minus 5 is released from the radical. And this is 3 to power of 3 is 20. So when you solve it, x is 4. You know, when the root is 3 or odd numbers, we don't really have to check because it doesn't matter whether number is positive or negative, because the root is odd, it's going to work. What if you have one radical on each side? When you raise both sides, both radicals are removed. See? And x equals 7. And I want to check, you know, you put that one here, so it would be radical 7 plus 4, and here would be 2 times 7 minus 3, so it would be radical 11, and this side it would be radical 11. You could also check like that. Now, both sides have cubic roots, so raise it to power of 3 in order to release the radical. Same thing. Both sides raised to power of 2. So these two problems are all kind of very similar. you have radical on either side, and you have to see what the root of the radical is, and then you raise both sides to that. Number 13, I believe I have a solution for that because it's a long problem. You take the whole thing, raise it to power of 2. Again, that means, how do I get this? You take this radical and multiply it by itself. And then when you take this and raise it to power of 2, look, negative 2 to power of 2 is 4. And this radical is removed because when we raise it to power of 2 and so on. So you have the solution for that. You know, we kind of touched trigonometry a little bit, and that is the Pythagorean theory. It's kind of very well-known formula that if you have a 90-degree triangle, and this is the symbol of 90 degree, it's just a box or a square. So this formula apply only to a triangle that has a 90 degree. One of the angles is 90 degree. In that case, the longest side, which is hypothesis, or the longest side, when you take that and raise it to power of 2, that would be sum of perfect square of each leg. One leg is A, one leg is B, so is that. Now, if I need to find the C, then you take a square root of this. If you want to find one of these two, then obviously you have to take the other one to the other side, so it's a negative. In these problems, we are looking for one of the leg. So we are using this formula. C, the longest side is given, B is given, you find the other one. 23 radical 5. When you raise it to power of 2, 23 is to power of 2. And what is radical 5 to power of 2? Just 5. And that gives you the value. Okay, that would be end of this section.